In November, a historic moment occurred. Woh G64 became the first star outside our Milky Way to be captured on camera by the Very Large Telescope. But this wasn't just any star. Woh G64 is an enormous giant, many times larger than our Sun, and ranks among the biggest stars ever discovered in the universe. Upon closer study, scientists uncovered something astonishing. Woh G64 is nearing the end of its life and is on the verge of a massive explosion. This dying red hypergiant is expected to produce the next supernova visible from Earth. But what signs point to its imminent and violent demise? And how did astronomers manage to capture such detailed images of a star located 160,000 light-years away? Stay with us until the end as we uncover the thrilling revelations from this incredible observation of a cosmic giant. In our daily perception, the Sun often serves as the standard for cosmic scale, and for good reason. With a staggering diameter of nearly 1.44 million kilometers, our Sun is so vast that about 1.3 million Earths could fit inside it. But that's just the beginning. Our life-giving source of heat and light, the Sun, holds an incredible 99.86% of the entire mass of the solar system. Yet, when we compare it to other structures in the universe, something surprising becomes clear: our Sun is not an especially large star. In fact, it's just a medium-sized yellow dwarf, an ordinary representative of the main sequence stars. However, far beyond the norm, there exist celestial giants of truly staggering proportions, making our Sun look like nothing more than a tiny, glowing speck. One such behemoth is Woh G64. Residing in the Large Magellanic Cloud, about 160,000 light-years from us, this massive star outweighs our Sun by 16 to 22 times in mass alone. To give some context, despite its name, the Large Magellanic Cloud isn't an actual cloud, but a satellite galaxy of the Milky Way, and the fourth largest galaxy in our local group. Though it contains only about 5% of the stars found in our own galaxy, it's home to one of the most colossal stars ever discovered, an immense giant approximately 1,700 times the size of our Sun. At the same time, Woh G64 emits a staggering 280,000 times more light than our Sun. As mentioned earlier, it's also among the largest stars ever discovered in the universe. Yet, this colossal star is already entering the final phase of its cosmic existence. Observations of the red hypergiant reveal that it's shedding massive amounts of gas and dust from its swollen outer layers, forming a dust ring spanning roughly 30,000 astronomical units. To put that in perspective, 1 astronomical unit equals the average distance between the Earth and the Sun, about 150 million kilometers. Now, for the first time, we have a rare opportunity to closely examine this dying giant and its strange environment, not through a simulation or computer model, but via a direct, detailed image. This marks the first ever close-up image of a star located outside our galaxy. Thanks to ongoing advancements in telescope technology, astronomers can now capture detailed images of distant stars and even exoplanets, transforming these once blurry points of light into well-defined celestial objects. Until recently, scientists could only capture detailed images of nearby, massive stars like Polaris and Betelgeuse. Stars beyond the Milky Way remained out of reach for traditional imaging techniques. But that has now changed, thanks to groundbreaking work by a research team led by Kayonaka at André Bo University in Chile. Using the gravity instrument on the Very Large Telescope, which analyzes data in the near and mid-infrared spectrum, the team managed to capture a clear portrait of Woh G64. This remarkable image not only places the star at the center but also confirms it is enshrouded in thick dust and surrounded by a distinct ring of debris. In short, the image offers unmistakable evidence that this giant star is nearing the end of its life. But there's more. The photo reveals that the dust and gas cocoon around Woh G64 has a surprising shape, one that defies previous assumptions. Rather than a simple spherical cloud, it forms an egg-shaped envelope tightly wrapped around the star. The reason behind this unusual shape remains unclear, but one plausible explanation is that Woh G64 expelled its outer layers unevenly during a powerful eruption. Alternatively, the unusual shape might be caused by the presence of a previously unknown companion star. True to the saying that one cosmic surprise rarely comes alone, researchers also encountered another unexpected finding. They observed that the star has undergone a remarkable transformation. Over the past 25 years, its near-infrared radiation has increased significantly, while its mid-infrared output has remained relatively constant. Astronomers believe this shift in the star's spectrum is due to the formation of hot dust nearby. As material is expelled by Woh G64, it first condenses into transparent grains made of aluminum oxide and magnesium silicates. These grains are later coated with iron-rich silicates, which absorb more radiation. This process intensifies the near-infrared emission from the heated dust, even as the star itself appears dimmer in visible light. So, when will Woh G64 explode? Co-author Jacco van Loon of Kiel University in the UK summarizes the star's condition by saying, Woh G64 is one of the most extreme stars of its kind, and any significant change could push it closer to a violent end. This naturally raises the question, when exactly will this dramatic explosion occur? And more broadly, why do massive stars meet such a catastrophic end as a supernova? In short, Woh G64 has reached a stage where its primary fuel, hydrogen, was exhausted long ago. Inside the star, fusion has already progressed to heavier elements like helium, carbon, and oxygen, which are burned in successively hotter layers. Eventually, this process reaches its final stage, the formation of an iron core. However, iron represents a crucial limit. Unlike previous elements, it cannot be fused into heavier ones without using more energy than it produces. Once enough iron accumulates in the core, the delicate balance between the inward pull of gravity and the outward push of radiation is lost. When the core surpasses a critical mass, it collapses under its own gravity in a matter of seconds. This collapse generates extreme temperatures and pressure, triggering a colossal explosion. The outer layers of the star are violently expelled into space, marking the dramatic end of its life as a Type II supernova. Given the immense size of Woh G64, this explosion won't be subtle. It will blaze with the intensity of an entire galaxy, even if only briefly, and may be visible from Earth across the vast expanse to the Large Magellanic Cloud. In fact, we might even witness this spectacular finale with the naked eye, though, of course, is a relative term depending on when it happens. While astronomers can't pinpoint the exact moment the supernova will occur, they estimate it could happen sometime within the next 1,000 to 10,000 years. Although it's unlikely that we'll witness this event ourselves, this vast stretch of time is merely a fleeting instant when viewed on a cosmic timescale. For future scientists, the true importance of the supernova won't just lie in the explosion itself, but in its aftermath. Such monumental cosmic events hurl vast amounts of heavy elements, like iron, nickel, gold, and even uranium, into space. These elements are critical for forming new stars and planets, and ultimately, for enabling life as we know it. This concept becomes even more profound when we consider that our own sun is classified as a population 1 star. That means it formed from enriched material, gas and dust that had previously been processed through one or more generations of stars and supernovae. Earth, too, with its abundance of metals, minerals, and life-sustaining elements, is a direct result of this stellar recycling. Beyond that, a supernova acts as a natural laboratory for astrophysics. It provides a rare opportunity to study phenomena like core collapse, neutrino emissions, shock waves, dust formation, and even the birth of exotic remnants such as neutron stars or black holes. Ultimately, the star Woh G64 won't simply vanish from the cosmic scene. Whether it becomes a neutron star or collapses into a stellar black hole will depend on the mass of its remaining core. If the core is massive enough, the collapse will go beyond forming a neutron star, giving rise instead to a gravitational giant. In typical fashion, such a black hole will remain hidden from view, detectable only by the glowing shell of gas and dust it leaves behind after the explosion.